In this edition of Grade Game, we're looking at nuclear equations. When we're working with nuclear equations, there are four fundamental particles that we need to know about. There is our alpha particle, there is our beta particle, there is our gamma ray, and there is our neutron. Now, an alpha particle has a mass of 4 and a charge of 2 and has the symbol A from the Greek alphabet. Our beta particle has a mass of 0, a charge of -1 and the symbol for beta from the Greek alphabet. Our gamma ray has 0 mass and 0 charge and has the Greek letter for gamma, and our neutron has a mass of 1, 0 charge and has the letter N as its symbol. Let's look at an example of a nuclear equation. Let's start with uranium-238. It has a mass of 238 and it has a charge of 92, so it has 92 protons. Now uranium decays by alpha emission, so we write in our alpha symbol. Now that leaves us with an unknown. We need to work it out. We have to do some basic maths, just addition and subtraction. If we look at the mass numbers, we've got a mass of 238 and a mass of 4. So we've got a missing mass here. That number plus 4 must add up to 238. So that means that we do 238 minus 4 gives us 234. So that's the mass number that we're missing. We do the same on the bottom line. We've got 92 protons here and we've got 2 protons here, so 92 minus 2 leaves us with 90. Now if we look that up in our periodic table, we can see that the element with the mass number of 90 is thorium. Now if you see that on the exam, it looks like a whole load of just symbols and gobbledygook really. So let's break it down so that we know what we're doing. The numbers we deal with in 2 parts. Everything above the brown line and everything below the brown line. Now, if we split the equation this way as well, the number on this side must equal the numbers on this side. The number here below the brown line must equal the numbers over this side. So 238 must equal 234 plus 4. 92 must equal 90 plus 2. And so we can see that it's just some basic arithmetic. Let's have a look at another example. On the left hand side of the equation, we've got 239.94 Pu for plutonium. That decays by giving off an alpha particle. So whatever we've got on the left hand side, we must have on the right hand side. Working on the top line first, 239 and 4, so we need to have 239 on this side, so that leaves us with 235. Looking at the bottom, we've got 94 on the left hand side, we've got 2 on the right hand side, so that leaves us with 92 missing. Look it up in our periodic table, we know that 92 is uranium. Now it's your turn. Have a go at the bottom one, pause the video now, and then we'll go through it together. So let's see how you did. Working on the top line, we've got 24 plus 4 here, gives us a total of 28. We've got 27 on this side, so we are missing 1. On the bottom, we've got 13 this side, and we've got 13 this side, so we are missing 0. If we look back at our work at the start of this video, we saw that anything with a mass of 1 and 0 charge is a neutron. So our aluminium has absorbed a neutron and then done an alpha decay to form sodium. So let's summarise our rules. Number 1, what we have on the left hand side must equal what we have on the right hand side. Number 2, the charge on the left hand side must equal the charge on the right hand side. And number 3, the mass on the left hand side must equal the mass on the right hand side. And we can summarise that by drawing 2 lines. So this quadrant here must equal what's in this one, and this one here must equal what's in this one here. Thanks for watching this Grade Gain video. Don't forget you can subscribe to my channel by clicking on the Grade Gain logo that's appearing on screen now. And don't forget you can also watch any of my other videos by clicking on any of the playlists on the side. You have been watching Grade Gain.